Hello, everyone. Thanks for coming to my talk. Is it too loud? Or is it okay? All right. My name's Paul Watson. I've been a security engineer at Google for just over 9 years now, I guess. And one of the things I did when I went to Google was worked on network security, which is all our production environments, our corporate environments. They were really, really large back in 2004 when I started, and they're incredible now. And one of the problems we had was it was very manual, labor intensive to maintain all the network access control lists, all the firewalls, all the filtering, just a huge manual task. And so after a very short time of learning the environment, I wanted to set out and figure out how to way to automate it, get myself out of the loop. And that's kind of where this talk comes from, is some of the tools I wrote and later open sourced. One thing, how many of you guys go to a lot of security conferences, or more than one a year? Something just hit me today that I'm just going to bring up. I wasn't going to say anything, but it seems like every security conference, someone is talking about Aurora and APT and the Google attack and everything. As someone who was part of like the 15-person core team at Google that actually worked on it, take everything you hear with a grain of salt this size, because there is a lot of FUD out there of people talking about it that really just don't have a clue. All they know is what they read in the paper, but it makes great stuff to talk about at a security conference. But yeah, you're not really going to hear a lot of facts about it. Certainly not from this talk. So I'm going to do something that a lot of speakers won't do. I'm going to tell you how to tune out my talk and not even have to bother with it. So this is the one-shot slide. If you want the code that I'm going to be talking about, you can go to code.google.com/p/Capirca. If you've ever watched Battlestar Galactica, the new season, about halfway through the series, they landed on this new planet called Capirca, which was the new homeworld, or new Capirca. This was our new way of generating ACLs, so I called it Capirca, but it turns out I misspelled it. So it's Capirca. Now you know where the name came from, why it's just kind of a weird thing. If you click on the downloads link, there's a download called Capirca 242 TGZ. You can download it, extract it, CD into the directory, and simply run aclgen.py. This is a very Python-focused talk because everything I wrote was in Python. I love Python, it's the shit. And for you Perl guys, I used to be a Perl guy. Once you get into Python, you won't be anymore. And what it will do is it will take a bunch of these policies that we started with that are sample policies and generate ACL filters out of them. And you can look at the result by going into the filters directory and seeing all the generated files. If you want to play with it, you just go into the def directory, definitions, and there's things like network definitions. This is my DMZ. These are my web servers. These are my mail servers. These are my offices. And you just change those addresses or those net blocks. You can modify policies by going in the policies directory, taking the existing policies, tweaking them around, playing with them. Run aclgen again, look at the filters to see what the output looks like. And then once you're like, okay, I know how to play with it, if you want to actually learn how to use it and get a little more info, if you go on the wiki on that code page, the wiki has tons of docs from a quick start guide to how the libraries function, how to add code to it, all the capabilities of writing an ACL term. But we'll get into more of that in a minute. This is just for those quick start guys that just want to sit there and play with it for the next hour. So you have to picture the epic music, you know. Not quite there yet. And I'm a huge Star Wars fanatic, so everything's got to be Star Wars themed somehow. So a long time ago, ACLs were basically really poorly, written by hand. Yes? Okay. And this is basically what an ACL would look like, a simple Cisco ACL. We got a little bit of IPv6, full IPv4. And this was all written by hand, maintained by hand, then you'd cut and paste it into your router. And it has a lot of challenges doing this by hand. First off, if you're dealing with a very large network, you've probably got a whole lot of ACLs. Some companies are fairly small. They've got one little border ACL on a Cisco they maintain, and it's one file. It's 50 lines. It's very simple. This could help you, but it's not going to give you as much help as if you have 20 ACLs you're maintaining that share common lists of, here's all our CIDR blocks we maintain, here's a list of all our servers. So you've got to repeatedly put these into different terms and access lists. Maybe you've got some Juniper routers, you've got some Cisco routers, you've got an SRX box, you've got a Cisco ASA, and you need to replicate a lot of these policies across. This will help simplify that. They can be extremely difficult to review. So your manager comes in and says, hey, I need you to spend the next quarter, go over all of our ACLs and make sure they all make sense. Make sure they're doing what they're supposed to do. Look, you've got a 4,000 line Cisco ACL, you'd rather put a bullet in your head. I mean, that's just horrible grunt work to do. And of course, anytime you're doing something repetitive by hand, you're going to get a lot of typos. And you're not going to notice the typos until someone says, hey, why is SSH open on your web server? Oh crap, I put 80 instead of 22, or 22 instead of 80, or added something in that wasn't intended to be there. Maybe I got a net mask wrong and I've opened up more servers than I intended. Anyway, lots and lots of problems. So the way we used to do it was we'd have search and replace. You know, why update one file and then go to the next and go to the next? I'll just use awk and sed and grep and dig through a lot of files and manually replace them that way. You ended up as a network administrator having to pretty much memorize where everything was in your network and what every subnet was and what the masks were. You'd throw in tons of remarks to keep track of everything. You know, maybe if you had something like a checkpoint system, you could say, well, compile this checkpoint to a Cisco filter. But it was very limited. It could only do certain things, and you know, and you'd have to buy the add-ons for it. Kind of a pain in the ass. So what I wanted to build was a common language. One way to write an ACL policy at a very high level that's easy to read, you know, allow from the internet to my DMZ just web. You know, very simple descriptive language. You're not really having to deal with protocols and ports and net masks. It should be clear and easy to read. Policies should share common objects and definitions. Seems pretty obvious. And automate as much as possible to get people out of the picture. Another thing I recently added was include statements. So it's very much like a programming language for network filtering. If you've got terms, you know, 4 terms that you're constantly repeating over and over to say, allow ICMP, allow traceroute, allow SNMP, and you don't want to have to keep putting that in every one, you can just create a policy and say, include common services. And it just imports those filters in. If you ever want to change it, you change it in one place. All the new ACLs that have that include get included. And most importantly, and this is really critical for Google, validation and testing of policies, which is something that doesn't get done a lot in network security. I've created a 4,000 line ACL. I'm trusting that my whole network is going to be defended by this ACL, and it's got to be right. Well, what sort of unit testing do you do? When you make changes to it, how do you validate to say, this is always right, this is always wrong? There really isn't a lot of ways to do that today. So real world, copying policies to a new platform. I got it all in Cisco today. Tomorrow my network team comes in and says, we just got a great deal from Juniper. Rewrite all these policies for the new platform. With the old school way of doing it, now you're having to rewrite a new ACL from scratch. With the new way, you basically just change the target from Cisco to Juniper and run ACLgen. Bam. You've got the exact same policy on the new platform. Defense in depth strategies. I want to apply this policy on my network edge, or maybe I'm deploying it to a specific zone internal. It's got all my HR systems. But just to be safe, in case the network guy screws up, I want to apply that exact same policy on that switch to the individual hosts. So I want to compile it to Cisco, and I want to compile it to IPtables or PF. You can do that here. The unit tests. Ensure that port 80 is always allowed to my web servers before I push this ACL out. Make sure that port 22 is never allowed to my DMZ machines. And make sure, another thing which commonly happens, make sure that if it's allowing port 80 to this machine and it's saying true, that it matches on this specific term, not accidentally matching on a different term, which actually means you have an error in there somewhere. Avoid duplications. Be able to work with IPv4, IPv6. Verifying against recent traffic scenarios. A lot of networks collect net flow data. Well, if I've got net flow data from last week, and I'm pushing out a new ACL today, wouldn't it be really cool if you could take that NetFlow data and say, let's look at last week's NetFlow data, apply it against this week's policy, and get a report that says, here's the changes. And then compare it against what changes we thought we made to the new ACL. So that way we get kind of an assurance testing that things actually happened right. And modifiable for new platforms. So here's kind of the high-level overview. I wanted to write it in a modular fashion so that we could independently test each module. We could ensure that they do what they're supposed to do, and more importantly, we could use them in different ways. So over here, I've got a list of the core components, I guess. We've got a naming library. The naming library is what interprets our definition files, our network files, and our service files. The naming library is useful because what if I don't want to generate ACLs, but another team wants to read those same definition files and apply them to something entirely different, such as a network inventory database? They can just use our naming library and read those exact same files and get the exact same data out of them for entirely different things. Our IP address library, of course, is important because we've got to know how to read an IP address or a net block or a CIDR block and manipulate it and work with it. We'll talk more about each of these later. The policy library is how we interpret this high-level language network policy into an object. And now that I've got an object, I can take that object and just output it in many different ways, which are what we call generators. So now I read in a bunch of definitions, I read in a policy, which uses those naming definitions, and then I create this object construct that I call my policy, and I pass it to the generator libraries, and Juniper knows how to take that exact same library and create Juniper output. The IPtables Speedway library knows how to create IPtables output with it, and so on and so on. And we've got tons of platforms we support now. And of course, at the bottom, we've got ACLGenPy, which is our compiler. So this is kind of what the flow looks like. We take our definition files, and they can be anything like DMZ.net, HRsystems.net, corpsystems.net. And we just create them all in one directory, whatever structure you want that makes sense for your organization. We create service files that contain things like HTTP equals 80/TCP, stuff like that. Naming reads that in. It takes all the network addresses and uses the IP address to represent them in a common, easy manipulatable way. And it passes that information to the policy library here. The policy library then reads all of our policy files, which is our high-level descriptive language of our network policy, and uses the naming to create that object. And then it passes it out depending on the policy. If the policy has a target that says Juniper, then policy says, well, I need to pass that down to the Juniper library to generate output. If it also has a target called IPtables, also pass a copy to IPtables, and the resulting output is their filters. How we do? Man, I'm going way slow here. We'll just kind of blow by that. Real quick though, initially it's all built command line because my original thought was if I get it all run command line, easy editable files, it'll be very easy to eventually put into a nice web GUI or some sort of user interface. And it turns out that hardcore geeks actually like the command line and hate GUIs. So if you ever want to overlay a web GUI on it, go ahead. We could probably release them as a side project that would overlay on it, but we've decided not to actually ever try and push this into a GUI system. Our in-house system has several key differences from the open source version. One, we integrate very tightly with Perforce so that every ACL change gets code revision. We can keep track of what's changed, when, who did it. Internally, we use an IPtable system, which is modularized. So for a given system that may be an HR system, we'll say, well, there's the base module, then we will add in the HTTP model or the web services module, then we'll add in the management module, and it combines all these to create one IPtables policy, and we use a special loader for it. For most people, you're just going to use the Speedway, which creates a single long IPtables output. It's much better. And then you can just run IPtables restore on it, and it sucks it in. We also have a lot of integrated push tools for all our router ACLs, our IPtables, and whatnot. So we've got our own internal code tree, but we port the changes back and forth whenever I get time. So we'll look at the naming library real quick, and I've already talked about this. So this is what it would look like to define, say, RFC 1918 space. You just say RFC 1918 equals 10/8. You can put a comment after it. You can then re-tag it, so you say internal equals RFC 1918. You can have IPv6 and IPv4 on the same line, loopback equals. If you're only generating IPv4 output, the naming library and the policy library knows I don't need to reference the IPv6 when I'm only generating IPv4 output. You can define a bunch of offices individually with nice descriptive tags and then say our offices equal and join those all together. Same thing, identical to that with the service definitions. This is more on the coding side for people that want to build into the tools. So to use this naming library, you would just in Python import the naming library. You would create a naming.naming object. The only argument to it is a path in your network that contains those .NET and .svc files with all your definitions. And you get this definitions object. And when you look at the different methods on it, you've got things like getNet. And you can just say getNet RFC 1918, and it's going to come out and say, oh, it's 3 different IP adder objects. And this is important to note why we give these IP adder objects. We'll show on the, I think, the next slide. Is basically manipulation. You can do things like get service DNS. It'll return 53 TCP, 53 UDP. If you're only interested in the TCP stuff, you say get service by proto DNS TCP, and it'll just return 53. The IP address library, real simple to use. Import NAC adder for network access control addresses, and you say an IP equals a nacadder.ip, and you give it an address with a net mask, a comment, and a token name. And the token name might be something like whatever you read out of the definitions file, like RFC 1918 or RFC 1918_10. Once you have it in there, you get all these wonderful things you can do with the IPs now. You can say, well, what's the IP version of this particular object? And it'll give you a 4 or 6. What is the text comment that came in with this? What is the token it's in? Oh, this is in internal. What's the parent token? Oh, the parent token was RFC 1918, because remember how we can nest? You can request the prefix length. How many hosts are assigned in a given address or netmask? There's a bunch of other methods, like IPEXT, extended address. It just gives you the IP address itself, and you can ask the netmask, hostmask, broadcast. So just this library alone is incredibly useful when building network access control tools or any sort of IP address manipulation in Python. There's a lot of other methods available, like you could just get integer values for them if you wanted. So you have to play with the libraries to see all the wonderful junk in there. The policy library, real quick description, we talked about this. It's got 2 key sections, a header section, which defines the filter target, Cisco, Juniper, Cisco ASA, and the terms, which are your actual policy rules you want to implement. And the policy language, this was kind of a big deal right here. Because when initially trying to do it, some platforms allow you to do things that others don't. So how do you write one language that does stuff for everybody, but at the same time can be kind of a cross-platform language? So we came up with the idea of optional and required keywords. Every generator must support these required keywords: source address, destination address, protocol. And then we have some optionally supported keywords like source prefix, stuff like that, QoS tagging, that some generators might support and others might not. So if you want to write a guaranteed cross-platform policy, you would only use required keywords, because then you're not using that functionality that's Juniper only, for example. So this is kind of what it would look like if you're writing a new policy. You would start the header section, which is enclosed in curly brackets. You can throw a comment, 2 comments, whatever you want in there. And then you define the targets. So in this one, we define a target that says, I want to compile this to Cisco. We're going to call it edge inbound, and it's an extended access list. We're going to have a target of Speedway, which, for all intents and purposes, is IPtables. This is the IPtables you want to use. And it's going to be an input filter, and the default action should be drop. And we're also going to compile for a Juniper router, and we're going to call the filter edge inbound. And we create multiple terms, and the first 2 we show here, we say the term will be called discard spoofs. If the source is 1918, deny. The next one says permit IPsec. If it's from the remote offices and it's going to our VPN hub on this protocol, accept. A lot of times people will put protocol of TCP, UDP, or ICMP. It'll also accept arbitrary numbers if you have non-special or non-traditional protocols that you're using. So then you run ACLgen, it creates these filters, and you look at the output of the filters by cat example.acl. So this would actually create, when you run it, whatever that file name was, if it was in this case example.pal, it's going to create 3 output files in the filters: example.acl, example.jcl, and example.ipt for IPtables. And you'll see that basically it throws in some content revision tags so that you can import the data and it'll replace those. These ID tags are for Perforce. It'll throw in the no IP access list extended and the name we gave it, edge inbound. IP access list extended, edge inbound defines your new access list, and you just cut and paste it into your router and it's applied. For IPtables, we get the exact same policy, but only in an IPtables format. So we say our input filter, we're going to drop by default. We create a new jump table called discard spoofs. We append these rules to it, and then we append to the input filter a jump to discard spoofs. So your input filter actually will only contain jumps to each term, and terms will be defined independently as in the jump tables. And da-da-da, you go on down. You get more complicated ones, you see things like this: permit IPsec, protocol, source, we're going to track state, new and established, on and on and on, and then finally you get the commit. So you run IPtables restore on that and it gets loaded into your system. And a Juniper router, of course, has a completely different format, and this is what it would look like, the exact same policy rendered slightly differently. If you happen to be a Lord of the Rings fan and a Star Wars fan, yeah, okay. Currently, we got about 7 generator libraries that have been written. About 4 or 5 of them were written at Google. The rest have been written by other people out in the open source community. Stanford's Linear Accelerator, for example, used Cisco ASAs, and they asked us if we could build it, and I'm like, I really don't have time. And a week later, he sent back, here's some patches to get Cisco ASA generation done off this. It was phenomenal. I love getting patches from the open source community. SRX was also done. We started it internally. We got a patch from someone else that said, here's an SRX generator, and then we had a bake-off against the one that was developed internally versus the external one to see which one did a better job. And I hated to tell the guy, but the internal Googler that wrote the SRX generator actually had the better version, so we used his, and I hated to turn away an open source contribution, but at the end of the day, it's about the usage, it's more important. So the Juniper client, we can generate 3 different outputs: IPv4, IPv6, bridges, Cisco, extended standard, object groups, which is basically extended with object groups, IPtables, IPv4, v6. How important is this? By default, if you just create a Cisco and specify, yeah? Hell no. I'm sorry, that's not the plan. We haven't at this time, but we're exploring all opportunities. For Windows? God, why would anybody put anything important on Windows that they want to protect? Yes, we would accept patches for Windows. That would be a wonderful addition, in all sincerity. I just don't use it that much, so I'm not going to invest a lot of time in it. But yes, it would be nice. So Cisco by default defaults to extended. You can create a simple standard access list, like a access list 10. You can create the object groups if you want to work with the definitions more variably. Each term, as you noticed earlier when we were looking at it, so that when you actually get the output, sometimes if you just rammed all of the access list terms together, it's very hard to interpret, but if you go and look, we'll put this term discard spoof says these terms all apply to that, or these policies all apply to this one term. So you kind of know how each term actually gets done if you want to walk through and manually verify everything. So for Cisco, the arguments would be in your header section, a target Cisco, you give it a name, whatever you want it to be, and then you can optionally say extended, standard, object group. I want an INET6 only policy, or I want a mixed, which would be your IPv4 and IPv6 together. For a standard ACL, just Cisco, the number, and standard. Cisco 10 standard, and it would generate a standard ACL. Now, of course, if you generate a standard ACL and you try to put things like ports and protocols and all that other fancy stuff, it's going to choke and die and say you can't do that. But assuming you work in network ACLs, you probably already know that. Juniper is our most fully featured generator because we use a lot of Junipers at Google. Many, many, many years ago, when Google was a smallish company with only tens of thousands of servers, we went to Cisco and we used Cisco everywhere. And we said, hey, how come all these other companies get these great discounts and you're charging us full price? And Cisco came back and said, well, you're just a small company. So Google said, F you. They went to Juniper and they offered them like this huge discount and said, we want to be your friend. So to this day, Cisco would practically hand us equipment for free just to get in there, and we're still using Junipers on all our core backbone networks. And they are a phenomenal, phenomenal platform. So since we use a lot of that, obviously we have all kinds of additional capabilities, and these are what we call the optional keywords. So if you're generating a Juniper-only platform, you can do things like your fragment offsets, your prefixes, loss priority, precedence handling, traffic types, on and on and on. It's so much cool stuff. On that Capirca page, code.google.com/p/Capirca, if you click on the wiki link, there's all this documentation, and in the policy section it tells you about each generator and what keywords they support and what functionality they have. Juniper is another one, real simple. When you're creating the header section, you just say target Juniper, your filter name, and the type of filter you want. INET, INET6, or a bridge filter, if for anyone that uses bridge filters. They're kind of handy at times. IPtables. I'm just going to pass over this. Don't use IPtables. Let's just go with that. Use Speedway when you want to generate IPtables. IPtables was written for internal Google because we do things a little bit different with IPtables. You probably don't want to use that, so we'll pass right over it, and we'll go to Speedway. If you need to build an IPtables policy, use Speedway. And in that, you just say header, target, Speedway, what you want to hit, your input, your output, your forward, and whether your default policy should be accept or drop. You can also specify truncate names, because it turns out I found a little bug in IPtables. Yeah. Which platform? If the platform supports it, it'll be able to put it all together. Like Cisco can do it, but by default, it'll only generate IPv4, but if you say mixed, it will include both. For IPtables, you actually have to, or for Speedway in this case, generate two different files. So like one text file, you'd have one header that says target, Speedway, input, INET6, or INET. Then you would create another policy that says target, Speedway, input, INET6, and it will generate two because they have to be passed separately, one to IPtables restore and one to IP6 tables restore. And that's just because inherently Linux has two different capabilities to handle both of them. There's not one system in the kernel that handles both. And that's really what it comes down to. It's platform specific. If you want, it's not necessary. You can just apply your rules directly to the input filter and the output filter. If you happen to have a Linux box that has 18 interfaces and you want to do something different on each interface, you can just specify interface specific terms that's only applied to a given interface, ETH 1:4. By default, it's a state tracking filter, which means it keeps track of state, allows established flows through. If you want it to be a very rigid filter without any state tracking, and you want to handle that yourself by allowing established terms, you can use the no state argument, which turns off all flow tracking. The compiler, ACLgen. By default in the command line, you just type /ACLgen. It'll do all your compiling for you. There's a few other arguments you can use. Right now it comes with /def, which has all your definitions, But if for some reason you wanted to have definitions 1, definitions 2, and definitions 3 directory that you used at different times, you can specify your definitions directory with the -D argument. You can target one policy file by doing -P and the file name you want to compile with. You can change your output directory from the default of filters to wherever you want. The pol-dir, which is kind of the default, tells it, go into this directory and recursively go through every pol file you find and every subdirectory you find within there. Shade checking by default is enabled. Shade checking basically makes sure that this term doesn't occlude the term under it. So like if the first term you have is deny everything and then you've got this really extensive IPtables rule, it's going to tell you you're kind of not doing this right. Expiration info. One of the things we often do in network security is a guy says, I really, really need this. And when you go, no, policy says we can't do it. Okay, we'll give you a 30-day exception, but you got to have your stuff fixed after 30 days. Well, one of the problems we have is we'd put that stuff in there, we'd put remarks in there saying after 30 days removed from this date, and then it kind of never got removed, and then 6 months after you were supposed to remove it, it's still there, and you're like, well, I don't want to cut it off now, they might be depending on it. So one of the things we put in the terms, when you're defining a term, you can say this term expires, give it a hardcore date, and then when you run compile next time, if that date has expired, it'll generate a warning saying, I'm not rendering this term anymore because it's expired, to let you know that what it's doing. But then the policy will automatically compile without that term in there. And that way, when you tell someone this expires in 2 weeks or 30 days or 90 days, it will. Guaranteed. And you'll at least get the warning. You can also tell it, warn me 2 weeks in advance before you're going to start removing. So maybe if you compile your rules every day or once a week, you'll still get the warning in advance that this one's going to go away next week. Repeat that? IP any. So that you're aware of it? Yeah, if you did an allow IP any and say it was your third rule and you had 5 under it, that shade checking is going to come up and give you a warning that this term is kind of taking over all the ones underneath it. I mean, you can still screw yourself, but it's part of the game. But on that, let's talk about assurance and validation, which is exactly what you're talking about. One of the big reasons I wanted to do this at Google was now that I have a network security object that I can manipulate with code, play with. Because just trying to read an ACL with code and then create something I can look at and manipulate is really freaking painful. So this was a much easier way. Now that we've got this policy object, I can write a unit testing and validation framework around it, which is really cool. And this has given us some really big things. Most importantly is we don't want our customers to suddenly suffer an outage in Gmail because one of our guys fat-fingered an ACL. And it's happened in the past. And it's horrible. And it's because you're doing things at such scale that one mistake hurts so many people that when you multiply the pain all these people feel against what you did, it's like, wow, I just caused 80 years of damage, you know. It's like really scary stuff. Some of these tools aren't being released, but we're releasing the libraries that allow you to build this functionality on your own. And some of it can be done with as easy as a bash script using the code we've got. One is the ACL Check library. I won't even talk about the ones we're not releasing that much. I'll just briefly walk over them because I know I'm probably getting shorter on time. NetFlow validation, which internally we call Snackle. The load balancer validation, which we don't really use anymore. We do a different version of that. A policy reader library, if you wanted to find a way to nicely render it in a nice GUI somehow. Occlusion detection for terms. Over Christmas break on vacation one year, I wrote what's called pole position because we had this system called Speedway for deploying all our IPtables. And it suddenly hit me, I'm like, well, what happens if we deploy IPtables on all these machines? How do I keep track of them all and make sure that they're all getting updated? So part of the push that went out was over this Christmas break, was a small daemon that runs on every box that get these IPtables that occasionally pings back to a central collector saying, yes, I'm running IPtables, and then he knows to go check that box and say, what version of IPtables do you have? What's your role? What do you do with it? What's the current hash of your rules? What's the previous hash of your rules? And it collects all these stats and displays them in a real cool GUI. So the ACL Check library, which is released, and this is an important one, that's very easy to use. You've got an ACL, and you want to say, if I apply this traffic to this filter with this protocol and ports, what happens? So a real simple example, this is in the, when you download Capirca and install it, one of the policies it comes with is this sample multi-target policy, which compiles for like 5 or 6 different platforms. So we run this ACL Check command line, and we say, looking at this policy, -S12001 with this source address, and using protocol TCP and port 80, destination port 80, what would happen in that policy? And it comes back and says, well, there's 2 filters in there, edge inbound, and it would match on term permit web services with an accept. And there's a second filter called edge outbound, and it would match on the term called default accept. And we know for sure that that traffic will match on that term with that result, accept. And that's really cool to know, because now you can say things like, these are my web servers, and I'm going to write a quick script that says, from a random internet address going to this machine on this port and protocol, what happens? It should always come back and say accept, and it should always accept on this term. And if it doesn't, quick tell me before I push this out because something's broken. I could also say, always make sure that if I run SSH from that same address, what does it match on? It'll match on edge input or edge inbound filter in this term, if accepted, default deny, because it's looking for established, and it knows it could match if it was established. And then it will also say default deny, so I know that SSH is never going to get through unless somehow someone already has an established session. And it would always be accepted in our filter edge outbound. Anyone sleeping yet? I know sometimes these talks can get really dry. So the cracklesnakkle stuff we wrote basically was making sure that we don't accidentally block services. Really useful stuff. This is kind of an example of what Snackle was. Basically, we take last week's net flow data that used to come through all our ACL filters. We look at what came through the filters. Now we've wrote a new ACL we're going to push out this week. But before we push it, let's take last week's network traffic, run it through this filter, the new filter we generated, and go, what's changed? What's the diff? And in this is an example report. It would say, a deny has turned into an accept for this packet sample we're pushing through. Or this accept has turned into a deny. Hey, we used to allow port 80 to google.com, and now we don't. Well, that's kind of important to know before you push out that ACL, because you can find the problems. And more importantly, since you kind of know what the changes are you did, by looking at that, you get a quick assessment of, are the changes that I put in what I would expect? Validation on the crackler. Basically, this kind of describes an older way we used to do it. We know certain services are out there because we've got jobs running in our production environment that are front ends for Gmail, for Hangouts, for all these wonderful things. Yeah? Which one? Okay. Oh man, it's going quick. And basically by taking those authoritative sources of what's actually running, and we know what needs to be live and what's a production service versus a QA service, we can import those and on the fly do an ACL validation check. So if there's a live production service that's flagged as serving publicly and it's going to be blocked by our policies, we should know about that before we push that new policy. And that's kind of what these reports look like. We built a little web interface, but unfortunately where the focus is kind of bad or it's really small text, one or the other. Pole position was our IPtables thing I wrote over that Christmas weekend. It collects all these reports from the boxes that are running out there and gives us a nice interface so that I can say that if you're running IPtables and you're running as an LDAP server, let me display all the LDAP servers we know about at Google and flag warning for any of them that, for example, has a hash mismatch. A hash mismatch means this is the IPtables policy I know should be applied, and the one that's currently applied generates a different hash, so something's wrong. An admin messed things up. Maybe the policy was, if the policy was unapplied, it would actually give you a warning that the policy is not applied. And we can actually break it down by teams so that each team can be personally responsible for going, let me go check all my Kerberos servers today. And they can just integrate it into their own process. Policy reader library is just a way to quickly go over it. So in summary, real quick, no evil, do no evil. The whole Google model, right? ACLs are prone to human error, so the more you can get the human out of it, the better. We went from a job that used to take 3 or 4 people working full-time, for an entire week, to something that one guy can do in an hour or 2 a week now, maintaining all our ACLs. It's done very quickly, very easy, huge efficiencies of savings, and I don't think we've had a single network outage caused by ACLs because of typos or errors since that time. Process-wise, we've still had some errors, but those aren't our fault. Code's been released to the public. Quick description over the Capirca name, and that's it. Questions? No? Okay. Well, thank you.